Hey guys, and welcome to Chem Squad Chemistry. This is Mr. Mullins. Today we are going to be continuing our Unit 5 discussion of naming different types of compounds. Specifically today we're going to be naming acids. So you should have already learned to name covalent compounds like organic compounds, and you should have learned how to name ionic compounds. If you've not already mastered naming ionic compounds, you might want to go back and take a little more time with that, because acids are a type of ionic compound. So we're going to be using some of those rules today to learn more about acids. If you could please flip to page 13 in your unit book and go ahead and read that page, and we are going to pick up on the next slide with the understanding that you've already read that page and know a few things about acids. Alright, so now that you have read page 13, you probably realize that acids are rather easy to name if you know your polyatomic ions. If you don't know your polyatomic ions, you're probably going to struggle with this, so you're going to need to get used to flipping back to the beginning of your book, page 1, to look at your polyatomic ions. So there are basically 3 rules that come along when we're talking about acids. Remember that an acid is something that starts with H in the compound. Water doesn't count, right? Because we know that water is not an acid. As a matter of fact, it's neutral because it's an acid and a base, can act both ways. But every other acid is going to start with H that we're going to be looking at. So that's how you're going to pick them up. The first rule is that if you have something that is considered to be binary, binary means that you have 2 types of atoms. Normally those things are going to end in "ide." If this happens to you, you are going to change the ending from "ide" to "ic." So you're going to change the ending to "ic." You're going to leave the root, and you're going to add a prefix "hydro." So you're going to have prefix "hydro." So that would be something that looks like this, HF. We know that HF is an acid because there is a hydrogen, so we can go ahead and write the word acid. We also see that it's binary, meaning there's just 2 atoms. This is not a polyatomic, so another way to think of this is whenever you see the word hydro, you know it is not a polyatomic, because polyatomics have their own rules, so it's not a polyatomic. So it's just fluorine. Literally all we have to do here is name the anion and put hydro on the front and ic on the end. So in this case it would be hydrofluoric acid, hydrofluoric acid. You can see that this would typically be fluoride, but we changed the ide to ic, so that's the first rule. It's rather simple, and we'll do some more practice with that in just a minute. Just want to show you what you're in for. The second rule is going to have to do with polyatomics. There are 2 rules that go along with polyatomics. The first of which is if the polyatomic ends in "ate," you are going to change the ending to "ic." There will be no prefix. If the polyatomic ends in "ite," you are going to change the suffix to "-os." So really just three rules. These last 2 apply to polyatomics, and we're going to use these to name various different types of acids. So all of this was actually written on page 13. There's even a little box there that tells you exactly what it is, but we're going to pick up on page 14 where we are going to practice naming all of these. So if you could turn to page 14 in your unit book, I'm going to work every problem on that page to help you with naming acids. So there on page 14 you see that HCl is the acid they gave us, and they want us to write the formula name. So we recognize that this is an acid because it has the hydrogen. So let's go ahead and write acid. Just do what we know, and we'll pick up where we don't know. We notice that this is not a polyatomic. This is just chlorine, a monoatomic, which tells us we are going to have to use the prefix hydro. We know that this is chloride, so the ide gets changed to ic, so this would be chloric acid. hydrochloric acid. Simply that easy. Our next example here, they went the other way. They gave us hypochlorous acid. We see this here, hypo. Do not get that confused with hydro. Hypo and hydro mean two different things. So here they gave us the words. They want us to write the formula. We see that it's an acid, so we know there's going to be a hydrogen. We know hydrogen has a +1 charge. We need to figure out what this hypochlorous is. We know that it's a polyatomic because there is no hydro. What else do we know about this? We also know that this ose came from somewhere. We know that it came from ite, from our rules from earlier. So if we were to rewrite this, this would be hypochlorite. This is a polyatomic that hopefully you've learned to memorize. Remember that chlorate is ClO3 minus 1. Chlorite would be ClO2 minus 1. And hypochlorite would be ClO minus 1. So here's our polyatomic. So we know that it's ClO minus 1. We are going to treat this just like an ionic bond because that's exactly what we have here. We have a positive being attracted to a negative, an ionic bond. We need to crisscross. Luckily for us, this time they are both 1, so my answer would be here, HClO. Alright, so our next two examples on page 14 is chlorous acid and chloric acid. Obviously we know both of these are acids. Let's start with chlorous acid. Because it's an acid, we know we can put H. It's going to definitely start with H. The next step is going to be able to figure out what is this chlorous. We know it's not binary. We know it's a polyatomic because there's no hydro. We know that ose came from ite. Right? So we're looking for what is chlorite. Hopefully you've memorized it by now. It's ClO2 negative 1. So our acid is going to be a mix of hydrogen and chlorite. So in this case we're going to crisscross. We're going to get HClO2. Over here for chloric acid, we're going to do about the same thing. We know that this is not binary because it does not have a hydro on it. We see that ic came from 8, so chlorate. Hopefully you know what chlorate is. We've been learning that for months and months. That is ClO3 minus 1. We know that there's also going to be a hydrogen involved because it's an acid. And when we crisscross, we're going to get HClO3. Next up, we have perchloric acid and HNO3. Again, we know that this is an acid because it says acid, so we know we're going to have a hydrogen. We know that this is not binary because there's no hydro, so this has come from 8 perchlorate. Hopefully you know per means that there's an addition of an oxygen to our polyatomic. So in this situation, it's going to be ClO4 minus 1. Here's perchlorate. And then we just need to crisscross HClO4. Over here, we're giving the formula where we have HNO3. We see that NO3 is a polyatomic. That tells me I'm not going to need the prefix hydro. Instead, I just need to name the polyatomic. In this case, it is nitrate. And we know that 8 needs to be changed to ic, so this would be nitric. I'm sorry, I misspelled that. Nitric acid. How do we know it's an acid? Well, it's because of that hydrogen. We're going to do 2 more examples, then you're going to be on your own. We have hydrobromic acid up next. We see the prefix hydro. That tells me that it is not a polyatomic. It's just simply bromic. Bromic comes from bromide, so we know that it is Br. We know Br has a -1 charge. We also know it's an acid, so it's got a hydrogen. So when we crisscross, we're going to get HBr. For our last example, we're going to be doing H3PO4. We can see here again that this is an acid because there's a hydrogen out in front. We also see that this is a polyatomic, so we need to name that polyatomic. That polyatomic is phosphate. phosphate. And we know that the ending ate needs to be changed to ic, so this would be phosphic acid. Now sometimes it's not written this way. You can kind of imagine that phosphoric acid sounds kind of weird. The actual real name for it is phosphoric acid. Phosphoric acid. So that gets added there, but we're not going to be super picky about that. So what I'd like for you to do is I'd like for you to pause the video now and finish the next few problems on this page, and then when you're done with them, I will show you all of the answers so that you can know if you got it correct or wrong. If you have not already completed page 14, again, you need to pause the video now and try them on your own. The only way for you to get good at these is for you to do them yourself. I'm going to go ahead and start showing you some of the answers, so be prepared to get the answers. First off, we notice this is an acid because of H. We also notice this is a polyatomic, so it's not going to start with hydro. That is actually phosphite. Ite needs to be changed to ose, so this would be phosphorus acid. Phosphorus acid. This next one, we see that it starts with hydro, cyanic, which sounds a lot like cyanide, acid. So here, instead of having cyanide as a polyatomic that ends in ate, it actually ends in ide. So that's why we have the ic there. So hydrocyanic acid, we know there's going to be an H. We know that because it's an acid, we know that cyanide is involved. So when we crisscross that, we get HCN. Next up, we see that there is an acid here with hydrogen, so we know it's an acid. We also know that this is acetate, noticing that it ends in ate, and we know that ate needs to be changed to ic, so this is going to be acetic acid. Next, we have carbonic acid. We notice that the ic ending comes from ate, so carbonate. We know that it's going to be a polyatomic. Carbonate is CO3 minus 2. We know it's an acid, so it's got a plus. So when we crisscross our answers here, we've got H2CO3. Lots of times people leave this 2 out. They forget that carbonate has that minus 2. Just like an ionic bond, we need to crisscross it. Next up, we have hydro. That tells me it's binary. Ends in ic, so that tells me simply that this is not a polyatomic. It is a monoatomic, and that is iodine. Sometimes it's hard to tell, but that's iodine. And we know it's an acid. So here we have H plus and I minus, so we have HI, hydroiodinic acid. And lastly, we have HF. We see that it is binary. It's not a polyatomic, so it's going to start with hydro. That might be a little difficult to see. We're going to start with hydro. We see that that's fluoride or fluorine. Ide changed to ic, so hydrofluoric acid. Hydrofluoric. Well, with that being said, you have now learned to name acids as well as write their formulas from the name. You should continue to practice. Your next homework assignment is going to be page 15. So if you can do all of the problems on page 15, that would be great assistance. There's 30 problems there, and you should be able to master that. Coming up next, we are going to be doing some mixed naming. So that means I will throw at you ionic, covalent, organic, and acids all at the same time. You're going to have to be able to pick them apart and know what set of rules to learn. So as you're practicing these, make sure you are recognizing if they're ionic, covalent, acids, or organic. That's all for today. Have a great day.